All right. Did y'all have a good weekend? Y'all tired today?
Oh,
Yes? All right, so everyone turn in their take-home quiz. It's due now. I won't accept it later.
I didn't get my quiz back.
You didn't get your quiz back? Oh, that's right. Give me another day to get it, okay? I don't. It's okay as long as your name's on the first page. Here we go. All right. All right, so we today are covering percent, ratio, and proportion. All right, and we kind of started last class with that. Were there any questions over homework or anything like that first? We're all okay? Yes? Which one?
I think on number 6, part C of 18. On the solutions, I think you had the wrong answer.
Well, they're not my solutions. So it may be. This one right here?
Yes.
Okay, so let's see. We have 32x squared minus 16x, and you're asked to factor out the GCF. So we looked at the numbers. We say what number can go into both 32 and 16? 16, right? So we have a 16, and then we look at the letters x squared and x. So they both have at least one factor of x, so we can place an x here. And then we need enough space for two terms. And so we just got to figure out what turns 16 into 32. So multiply by 2, and what turns x into x squared. Multiply by x. And then turn 16 into negative 16, you need a minus 1. You don't have to write it. And then x into x, you already have the x. So is that it?
Never mind, I got it.
You got it? Okay, so that's what it had? Do you see what happened?
Yeah.
Okay. Any other questions? Yes?
Supposed to do percentages from it?
No. You could have started it a little bit, but we're going to really cover that today. All right, well, let's do percents. So we said last time, just a quick review, that if you say something like n%, it means n over 100, or n out of 100. I think I may have used x% last class, but it doesn't matter what you want to use as a variable here. And remember that if you're going to convert, if you have a percentage, 74.3%, if you want to convert that to a decimal, it would be 0.743, right? So to go from percent to decimal, you move the decimal point 2 places to the left, and then rewrite it without the percent symbol. If you have a decimal and you want to go to percentage, you move the decimal 2 places to the right and then put the percent sign there. So those are really the main two things that we looked at last time. And we did a few of these problems, right? We said the idea was to try and set up an equation. So where did we get to on this? Did we just do number 2? Was that it? I did all of them? Let's see. Yeah. Let's start with the word problems then. Let's see if I can get all these. I can't quite get that in there. All right, word problems. Can you all see that okay? Number 7. So my goal here is like for me to work a word problem and then try and let you work a word problem. And just keep on switching like that. All right, but all these problems are different, so you have to pay attention to the wording, all right? 37% of all students at Northwest Vista College transfer to UTSA. Of these transfer students, 12% are going into biology. If there are 15,435 students at Northwest Vista College, how many of them will transfer to UTSA and major in biology? Pardon me? Of means multiply, that's correct. So what I recommend you do on problems like this is draw a picture, all right? Pictures can always help you get through the difficulties of a word problem. So I'm just going to draw this big blob, and that's going to be all the students, NVC students. All right, there they are. NVC students, that's all of them right there. And we're told that 35% of the students at NVC go to UTSA. All right, so that's a smaller part of this whole, right? This is all 100% of the Northwest Vista students. A smaller percentage, right? 37% are going, I'm going to put a little arrow, it means they're going to transfer to UTSA, okay? Of that whole, 37% are going to transfer to UTSA. So now let's kind of take a look at this group over here, right? That's that group right there, right? That's that group.
Where did you get 37?
I don't know where I got 37. Other than maybe my weekend was too good. 30%. Okay, 30% go to UTSA, all right? Of these transfer students, right, 12% are going into biology. So a smaller group out of this group, right, 12%, make it so I can write the word biology in there, right, 12% are going into biology. Make sense? My picture makes sense? And then they say, if there are 15,435 students at Northwest Vista College, that means this whole group right here, all of them, this was 15,435 was this big group, right? We want to know how big that group is. We want to know the number of students that transferred to UTSA and went into biology. Understand? So let's first try and figure out if we can determine how big this group is. So how do you determine this group?
15,435 times 20.
You're going to multiply this as a decimal times this. So let's try and convert that into a word, into an equation, all right? We want to know this. What is 30% of 15,435, right? Wouldn't this represent right here, this right here, is the number of students transferring to UTSA, right? Number of students that are going to transfer to UTSA is this equation, or this statement. What is 30% of the 15,435 students? Now convert that into an equation. What will be what? X is equals 30% written as a decimal, 0.30, you don't have to put the 0. And then of means times, and then 15,435. So let's just figure that out. Let's see if I brought my calculator here today. I brought a calculator. So 0.3 times 15,435. Is that right? What are you getting? What'd you get?
4630.
4630. Uh-oh. 0.5. So we're going to have a student, they're going to send half of their body over to UTSA, I guess.
For science.
Yeah. So we're just going to leave it. Obviously, you can't have half a person. Well, I don't know. I guess you could argue. Maybe there are half people out there, but all right. Let's just go off the numbers, all right? So this right here represents this big group, right? Now we want to know what?
12% of that?
What is 12% of that, right? What is 12% of that? So that the number of students that transfer and are biology majors, is going to be the following. We're going to say the same thing. What is 12% of this, right? So when I say what, I'm not going to use X again because I already used X. X represents the number of students that transferred. So I'm going to say Y, let's say. What is 12% of 46030.5, which turns into Y equals 0.12 times 4630.5. Hey, have y'all ever seen where people will write like 0.12 and then some other people will write 0.12? Y'all seen these two different things written before? Okay, just for clarification, the only difference between these two, obviously, is the 0, but the reason why people do this is because sometimes when you write 0.12 and you don't put a 0 out there, if you write the point real small, someone might not see it and they may think it's a 12. So if you put a 0 in front, like no one, if I asked you to write the number 12, you would never write that, right? So if you see a 0, it should like trigger in your mind, this is a decimal. That's all it is, okay? So I am in the habit of not writing the 0 because I can make my dots pretty pronounced up here. But if you want to put a 0, it's the same thing. All right, on the calculator, this is 555.6. Pardon?
I got 0.66. I don't know if that matters.
0.6, yeah, we're talking about people, so I think we're going to be okay. Yeah. So look, roughly what we're saying is this. About 4,630 students are going to transfer to UTSA. And of those, total of about 555 or so are going to be biology majors over there. Understand? Now, you could have done this problem all in one swoop if you are comfortable with it. Because what you're doing is you're starting with this, right? This amount. And you're first going to say, what's 30% of that, right? So you multiply it times 0.3. Whatever that answer is, you're going to take 12% of that, so you're going to multiply that times 0.12. So you could have done first the 0.3 times the 15,435, and then you could have said, okay, whatever that answer is, multiply that by 0.12. And if you do it all like that, then you get the same result. We just kind of did it in 2 steps because this is our first word problem. I'm trying to show you how to convert the words into a statement that you can turn into an equation that you can solve. We good? You want to try the next one? You try this next one. Let's read it first. 30% of all students at MVC transfer to UTSA. Of these transfers, is this the same problem? It's like, I know my weekend was good, but it wasn't that good. Seeing double already. Okay, so let's move on to, wait, no, hold on. That's not the same problem. Hold on. 30% of all students at MVC transfer to UTSA. Of these transfer students, 12% are going into biology. What percent of NV students are going to be at UTSA and major in biology? That's not the same question. Because look, it's saying, at the very end, it's saying, what percent of NVC students, right? Look at the previous question. How many will transfer to UTSA and be biology majors? So our answer here was, what, 555.6 students, right? That's how many are going to transfer to UTSA and be biology majors. Number 8 says, what percentage of the Northwest Vista students are going to be at UTSA majoring in biology? So let me ask it a different way. What if we only had 100 students at Northwest Vista College? And I went through the same process and I told you that 50 of them are going to wind up at UTSA and be in biology. What percentage of these students wind up at UTSA in biology? 50%, right? 50%. And the way you do that is you take this number, 50, and you divide it by this number. So it's how many you have over the total amount that you started with. So how could I do that for this problem right here that we just did? What's the computation I'm going to do?
Put 555.x over the 1500.
Yeah, this is how many students are at UTSA in biology, right? Okay, this is how many from NVC wound up over there. Now, to find a percentage, we take that and divide it by the total number of students we started with at NVC, and that'll give us our percentage here. So let's take 555.6. I'll keep the decimal and divide it by 15,435. And what do you get? It's going to be a decimal, right? So 555.6 divided by. This is 0.03599611127. I'm just going as far out as my calculator went. What I'm going to want you to do is your final answer is a percentage, just round it to one decimal place. So pay attention to what I'm saying. First, we have to convert this to a percentage. What is this converted to a percentage? 3.599611127%, something like that, right? But I only require one decimal point here. So how do we round? We look at the first decimal point, right? This is the one we want to round. We look at the number to the right of it. If it is bigger than or equal to 5, we round up. So this is a 9. That's bigger than or equal to 5. So I'm going to round this up one decimal point to 6. So round it up 1 unit to 6, 3.6%. All right. How about you try number 9? Let's see how y'all do with 9. Assume there are 425 statistics students at Northwest Vista College, of which 35 plan to attend nursing school. If you allow all of the students who plan to attend if all of the students who plan to attend nursing school are enrolled in statistics this semester, what percent of the 15,435 NVC student body plan to attend nursing school? So see if you can figure that out. Y'all can talk amongst each other if you'd like, but let's see if you can figure that out. Draw a picture if you need to. If you get something, let me know if you have an answer. Is that a yes? looks good. Anyone else have something yet? I've kind of drawn a picture of what you can use to get started if you're stuck. Yes, that looks right. Yeah, you rounded. You could round. That's okay. Yeah. Yeah, that's okay. Is anyone completely stuck and just needs help? I'm seeing some glossy looks. Are you getting anywhere on it? Okay. Did you get something, sir? What do you got? Yep. Okay. Good. Y'all are all good here? Yes? Your team, you sink and swim together, that's good. How about over here? How are we doing? So you're finding, what, 35% of 425 first? That's correct? So I think the part that you're missing is that this is correct. You find 35%, right? You got this many students in stats. 35% of them are going to go into nursing. So that was the first computation you got. What was it, 148? And it wants to know out of that 148 is what percent of the total MBC body. So instead of dividing this number by this, it's this number by this. Weird. Okay, how about over here? Is everyone, or no? Yes?
Yeah, I'm good. I think I'm good.
I'm gonna look.
You could be way off. You could be like, oh.
No, this is good. You understand it though? Yes? Okay. You okay?
I think so.
Y'all didn't check with each other? Let's see. Okay. The part that's missing for you is you never used that 35%. What you did is you said, this is how many stat students there are, the percentage of stat students over the total number at NBC. See, look, it's this group right here. You've got this 425 students, right, that are in stats. 35% of them are going to go into nursing. So you first have to find, what's 35% of 425. So you're going to do 0.35 times 425, and then that's the number you'll divide by the 15. Understand?
Yeah.
Okay, y'all were all good, right? Okay. Okay, so I think most of you are there. Everyone's going to do it different. Some people are just going to punch away on the calculator and get it. They're just going to do it mentally. Other people are going to have to write things down. It just depends on where you are comfort-wise with this. But you should be doing this computation first. We're trying to figure out how many students are going to go into nursing from this stats group. So we have to do 35% of 425. And when you do that, this is 0.35 times 425. And that gives you 148.75? Okay, that's how many students are going to go into nursing. That's it right there. And it wants to know what percentage of the total Northwest Vista body is going to go into nursing. So you want to know this divided by this to give you your percentage. So you're going to take 148.75 and divide it by the 15,435. And it came out to be approximately, what was it, 0.96? 0.96? Or no, 0.0096, wasn't it? And then you convert to a decimal by moving, or to a percentage by moving the decimal point 2 places. So it becomes 0.96%. You could leave it like that. You could round it. If you round this correctly to 1 decimal point, you look here, to the right's a 6, so you round this up. How do you round a 9 up? To a 10, right? Which means it becomes 1.0%. 1.0%. If you're rounding it. If you left this on the test 0.96%, I'm okay with that. Okay? All right, let's look at 10. In a Gallup poll of 976 adults, 68 said they drink alcohol every day. What percentage of respondents who said that, what is the percentage of respondents who said that they have a drink every day? This one is very straightforward. Yes, is it? Yes. That's a straightforward question because they give you how many you started with in the poll. It was 976. They tell you that how many drink every day? 68. And they want to know this as a percentage, so you just take 68 and divide it by 976, and that's it. So you want me to just put like 30 of those on the test? Just like that? 0.06967. So this is about 6.96%. You could round that to 7% if you want. All right. We'll see more percentages as we move on, but let's move on to the next concept, which is proportion. So I thought to start proportion out, I would start with an example that hopefully makes sense to you. Okay, let's say, as an example, that you have a job. Okay, you make $18 per hour. All right, let's say that's the job you have. You make 18 bucks an hour. All right. So I forgot to silence my phone, so I'm going to do that now. All right. So if you make $18 per hour, then you could write that this way. $18 per, we can look at as a fraction, per 1 hour. Now I think most people are comfortable if I ask them, okay, if you work 5 hours, how much are you going to make? Right? What are you doing to figure that out? Multiplying by 5, right? It's simple enough. But let's try it a slightly different way. All right? Just bear with me. How much do you make in 5 hours? Is it correct for me to assume that everyone is comfortable with, oh, you just multiply that 18 times 5 and you're done? Okay, but I'm asking you to look at it from a different perspective that might help you with these proportion problems. What I'm going to do is I set up this fraction right now, okay? This fraction represents what I was given, right? I was given this information. And I'm going to say that that is equal to, and then over here, I'm going to set up another fraction that's equivalent. And that fraction is going to include in the bottom hours, in the top it's going to be dollars. And that's because this was dollars, that has to be dollars. If this is hours, this has to be hours. How many hours am I telling you work? 5. You see that? There's 5 right here. So 5 hours, right? And up here is what I want to know, which is how much money you would make in that time. I'm going to call that X. Understand? Now, let's get rid of all the units. In other words, let's not concern ourselves with the hours and the money. Let's just keep in mind that our answer is going to be money, right? It's going to be dollars. And I'm just going to rewrite this as 18 over 1, that's 18 divided by 1, equals x over 5. And I know this seems more complicated, but trust me, it'll help us, hopefully, as we move into the harder problems. We are trying to find out what x is, right? And right now it's being divided by 5. I don't want this division by 5. To undo division by 5, I can multiply by 5. And what I do to one side, I do to the other. So I'm going to multiply this side by the fraction 5 over 1, and then I'm going to do the same thing over here, 5 over 1. On the right side, the 5's cancel, which is what we would have wanted to happen. And on the left side, when you multiply fractions across, just straight across, right? 5 times 18, 1 times 1. And there's your 5 times 18, which we knew it was going to be to start, right? What is 5 times 18? 90. So you're going to make 90, and then we have to remember, it was dollars, so $90. Understand? Now, I know that's a super complicated way to do the problem, but trust me, I think it's going to help in a second. I'm going to ask you a different question now, all right? Same situation, okay? You make $300. How many hours did you work? So someone tell me real quick how you would do this in your head or on the calculator. Anyone know what you would do real quick on this one? Divide this number by 18, right? 300 divided by 18. Yes, I agree. Completely agree with you. But I'm going to try and do it this way again. Why again? Because I'm trying to lead you into the harder problems and give you a systematic way of doing this. Because it will not be as easy as this. All right, so what are we trying to solve for here? Hours. You see that? Hours there? Okay, when I wrote this fraction down, right here, the $18 per hour, we could also have written the other way around. We could have written 1 hour will give us $18. All right, so this ratio, this proportion is the same. To say you make $18 in 1 hour is the same as saying in 1 hour you make $18. All right? And you are free to use either one of these. I am going to choose to use the second one because what am I trying to solve for? Hours. That means I want my hours on top. What were we solving for in the previous problem? The money, right? Dollars. So I use this one. The dollars were on top. So I'm going to use this fraction right here. I'm going to set up an equivalent proportion. I know I have hours on top, and I know I have the money on the bottom. How much did I make?
300.
What did I make? 300, right? 300, and this is the hours is what I want to know. Call that X. Yes? My answer is going to be the number of hours. And I'm going to convert this into an equation now without all those units, the hours and the dollars. It should be 1 over 18 equals what? X over 300. You want X by itself, right? So you multiply both sides by 300, or 300 over 1. And on the right, it goes away, you get X. On the left side, you get what we knew it was going to be to start, don't we? 300 over 18. So you do that on your calculator, 300 over 18. About 16.666, right? 16.7 approximately. 16.7 what? Hours. Okay? So the idea of proportion is this. Somewhere in the problem they're going to give you something that you're going to use. They're going to ask you a question, and what we need to do is use the proportion either this way or flip it in order to answer the problem. All right? But they are going to have to establish what the proportion is in the beginning. So let's look at this first one. This one should be pretty straightforward because it's the first one. one plain bagel, right? One plain bagel has 320 calories. How many calories are in 2.5 bagels? Okay? So one plain bagel has 320 calories. That's the part that they're giving me. I can write that how? One bagel over what? 320 calories. That's one way I could write it. Or I could write it which way? 320 calories over one bagel. Do y'all know what a calorie is? Yeah, like we all eat food and we need calories, right, to live? But do you know what 1 calorie is? Like, if you take, now I could be off here a little bit because it's been a long time since I've taken chemistry. But I believe if you take 1 cubic centimeter of water, so you know what a centimeter is, right? You take one little cube of water. The amount of energy or heat required to raise the temperature of that little piece of water by 1 degree. So you imagine you light a match under this and you start heating it up, right? That's heat. Heat is energy. The amount of energy required to change that little water by 1 degree is 1 calorie. That's what 1 calorie is. So when you think about how many calories you're taking in, what you're eating, that's being converted, you know, energy. Energy is heat. So anyways, if you didn't know what a calorie was, that's what a calorie is. But I might be confusing it with what they call a kilocalorie. But who cares? It has something to do with heat, though, and raising the temperature of water. That's how they measure it. That's how they can measure it, what a calorie is. All right, so here we go. We've got this, right? Now, what is it that they want to know? How many calories? So right now, which of those two are you going to use? The left one or the right one? The right one, because we want to know how many calories. This one has calories on top, right? This is the one I'm going to use. So I'm going to write it down. 320 calories over 1 bagel. And now I'm going to set up my proportion, must equal. Now tell me about what they... X calories is what I'm trying to solve for. In how many bagels? 2.5, right? 2.5. Now you have options on how you can write this. I like the 2.5. When they say 2.5, they mean 2.5. We do not like mixed numbers. You could write that as 5 halves, or better yet, as a decimal 2.5. The 2.5 I think is the easiest one to work with. So I'm going to do 2.5 here. That's it. So now I'm going to rewrite everything without all those things, right? And let's see what we get. 320 over 1 equals x over 2.5. And how are you going to get x by itself here? Multiply 2.5 on both sides. So I'm going to multiply by 2.5 here and multiply by 2.5 here. I don't need the parentheses around that. And if I want to, I could write it as a fraction. It's totally up to you. But these cancel. I'm left with x. And then equals, on your calculator, what is that? 800? Even? All right. 800. And then we'll put calories because we need to put our units, right? Whatever it is we were solving for. 800 calories. Let's see if you can do the next one. Please be very careful. Read the problem carefully. I'm going to step out for just a minute just to see if y'all can work together on this. Sometimes when I leave the classroom, people are more inclined to talk to each other. So I'm going to go get a drink of water. See if that helps. Did y'all see the tricky part of it? Did y'all catch the tricky part? We're gonna find out here. How many of you have an answer? Raise your hand. Okay, that's enough of us, I think, to move on. So, let's see. A leaky pipe can lose 24.7 gallons per 1 week.
7 days.
1 week is what they say, right? And what they're asking for is how many gallons, right, are lost in 30 days. So we need to either convert this 1 week to days, or we need to convert the days to weeks. What's easier? Week to days, right? I can change this. Instead of writing 24.7 gallons in 1 week, I can do 7 days. And that way everything matches up as far as my units. Do you all understand that? Please let's not get caught on the test with that, all right? All right, so I can use that, or I can use this. I can do 7 days over 24.7 gallons. My choice. But what they want at the end, right, is gallons. How many gallons? So I'm going to use the first one. So I set up my proportion, 24.7, and we can start to get lazy, all right? We can write G for gallons as long as we understand what that means. We can write 7D for days if we want. This must be proportional to X gallons over 30 days. And then your G's and D's don't matter anymore, and you set up this 24.7 over 7 equals X over 30. So how you do this is up to you. You're solving for X. You could, on your calculator, do this first. I'll do that. I'll do 24.7 divided by 7. Ooh, I get 3.528. I can keep going, but I'll stop there. Is X over 30. And then to get X by itself, multiply both sides by 30. So I'm going to do 30 here and 30 here. Multiply, these go away. So times 30. We're getting roughly, what, 105.9 approximately, X.
Instead of doing all that, can you just cross multiply and divide?
Cross multiply and divide. Well, yes you can, but why cross multiply? Like if you multiply, what are you going to get? You're going to do this times this, right? What number did you get when you did this times this? 741. Close enough? Equals what? 7x? Yes? Then you divide through by 7. So yes, you can do it, but I'm saying why do it? Because look, the 7 is already over here. X is almost by itself, isn't it? All you have to do is get rid of the 30. When you do this, you actually throw something over here on the right side with X again. So it works, but it only works because someone told you you could cross multiply at one point in time. And cross multiplication is just dangerous. I've seen it used so many times incorrectly that I'm not a big fan of it. Because it's just kind of like just a reaction when you say, I'm going to cross multiply without really thinking what you're trying to do. And if I'm trying to solve for X, I just need to get the 30 out, right? Multiply both sides by 30, I'm done. So yes and no. Yes, it's your own prerogative. You'll get the right answer. That's the good news. Okay, we didn't put the units. This is gallons, all right? So make sure you're putting the units on there. Yes. Okay, thank you. Thanks for letting me know. And I am not muted anymore. All right, let's move to number 4. That one looks a little more interesting. I think 3 is straightforward. Pardon? Oh, 3 is over there, yeah. All right, so let's do this. Number 4, a pre-election survey showed 5 out of 13 registered voters would vote in an election. At this rate, how many people would be expected to vote in a town of 5,850 voters? Registered voters, I should say. So let's write out the first piece of information. It's a ratio we're going to set up. 5 out of 13, right? 5 over 13, that fair? 5 over 13? But tell me what these represent. The 5 is what and the 13 is what? One of them is registered voters. The other one is the ones that are actually going to vote, right? Just because you're registered doesn't mean you're going to vote. So this is saying 5 out of 13 registered voters will vote. So 5 will vote, right? Out of 13 registered voters. It's important for us to label, what these parts mean. Look, only 5 are actually going to vote out of the 13 registered voters. Now, we are looking to solve for what here? What is it saying? How many people would be expected to vote? So am I going to be okay using this proportion, or do I need to flip it over and use it the other way? This one's good, because we want to know how many people are going to vote, and that's what's on top, the people who will vote. So I can use that. This needs to be proportional to registered voters, and on top will vote. And I'm given, right, I need to know what this is, X, and I'm told how many registered voters there are in this town. There are 5,850. And then all that other stuff doesn't matter, right? You can just write this as an equation. Does anyone have any questions? Yes, you could cross multiply. But I'm going to do it by just multiplying both sides by 5850. Multiplying this by 5850. And then I'll just work this out. I'm going to do 5 divided by 13 on my calculator, then I'm going to hit it with this multiplied. And I'm getting a number about, oh, wow, that's a nice number. 2250 equals X. And this represents the number of people who will vote, right? Will vote. Out of the whole town, right? Instead of just out of the sample. Ooh, this next one is tough. Not tough, but it's different. Read through that. Let's see if you can come up with that on your own. Put a star next to that problem. That has appeared on every test I've ever given in this class. A version of that problem. This is different, isn't it?
Oh, yeah.
This seems somewhat confusing. But I want to give everyone an opportunity to try and get to the right answer. And then we'll talk about it. If you have an answer, if you think you got something, let me know. Yes? I'm curious to see how people are setting this up. All right, so what did you do here?
Just cross multiplied and divide.
Okay, so that was a total knee-jerk reaction, I think.
Mm-hmm.
You just set up, 9 over 300, right?
Mm-hmm.
Yeah, I'm not quite sure that's going to get you there. Anyone else have something? I mean, you got to go with something. I value your effort. That there's 1.42? Yeah, there's probably not 1.42 trout in the lake. Do you have a question? You think it's 14,400?
No.
Oh, 1,600. Okay, so that's the same answer you got. All right.
Is this an okay setup?
9 tagged, 300 trout. And then what equals 40? Yes and no. Where's your X right now?
Total number of trout.
Yes, but where is it? It's on the bottom, right?
Oh, so just.
So I would flip it and it would be easier to work.
Okay.
What I'm looking for people to come up with the correct proportions with, you know, trout and all that stuff to see if you understand how to set this up. Yeah, that looks right. Good. So I'm not saying your answer is wrong here, but you need to understand what you're doing. You know what I'm saying?
Yeah.
That's all. That's all. Okay. Anyone else? 1,600? 1,600? Okay, there was a lot of 1,600s. All right, so I think I'll work it just to make sure we're all thinking of it the right way. Because I don't want someone to accidentally stumble upon 1,600 as the answer without having any idea of what they were doing. Because it is possible to do that, to multiply it just perfectly and you get the right answer on accident. So, all right, what is it that we're given? Just like I told you, you make $18 an hour, right? That was our initial starting thing. What can you tell me out of this? What is our starting information? 48 were captured and tagged. And then 309 were tagged. So what I'm trying to get at is, like the first problem I did where we had $18 per hour, and that's what we used. What is the piece of this one we will be using? 9 out of 300, okay? That we know for sure. We know that there are 9 tagged, right, out of 300 trout, right, that they caught. That for sure I know. Now, what is it I want to know? Estimate the total number of trout in the entire lake. So I'm going to use this, but I should probably flip it over, shouldn't I? Yep. Because that'll put trout on top. So I had this choice, or I could have gone 300 trout, and there will be 9 of them tagged. And that must equal the total number of trout that are in the lake, which is what I want, and how many of the total in the lake were tagged. See, the information was given to you backwards here. Look, they went out and they caught these fish, right? And they tagged 48 of them. There's only 48 tags in the lake, right? That's it. That's the total number of tags in the lake. So we have 48 tagged fish in the entire lake. We want to know how many trout are in the entire lake. So this thing is the entire lake. And this over here was the sample, right? But the sample is what set up the proportion, the ratio. And this is the way they do it. I mean, if they want to estimate populations, they go out there and they say, okay, we're going to put 48 tags out there. We're going to wait a couple of weeks. We're going to go back and we're going to catch fish. And whatever that proportion is should be close to the proportion of the actual population. And so it's an estimation. It's not perfect. Understand? And now if you get rid of everything, just 300 over 9 equals x over 48, and do your stuff. Is it coming out to 1,600? Yes. Equals x. And this is the total number of trout estimated to be in the lake. Things to be careful with. If you get an answer like 1.42, right, something like that, you know, you want to think about the answer a little bit. Like, it's not going to be possible to have that many fish. This seems reasonable, I don't know. Okay. Let's see what the next one is here. All right, some applications of percents. This is something that we use every day. There any, well, you don't have to raise your hand unless you want to. I used to wait tables when I was in college, so if you do wait tables, you don't have to tell us. You know, you rely on tips to make a living. So the other day I was out with my family, and they took me out for dinner, and my mom happened to pay. And you know, on the receipts now, a lot they have like, I don't know, they show the percent that you should pay for tip. It'll say like 12%, 15%, 20%. That way you don't have to calculate it yourself. Yes, have you all seen that? Okay. So my mom did it, and she's not a math person, so she just looked at whatever the 20% was, and she just wrote that into the credit card tip slot and then gave it back to them. So my dad was looking at the receipt later, and our bill was like, it was close to like $100, and the tip was like, I don't know, like $6 or something like that. And we were like, wait a minute, why is it $6? So we went back and looked, and it was so weird. The receipt, for some reason, right down the middle, the printer wasn't printing right down the middle, so it left out a 1. So it should have been $16, but the 1 didn't print, right? So it was only 6. My mom saw 6. She didn't think, okay, you know what I'm saying? Like when you buy enough food, you should know kind of ballpark of what the tip should be. My mom didn't. So we had to drive all the way back to the restaurant and hand the guy